testing to see if you learn how to factor from back in the day. So it's just really testing your factoring skills. So I would suggest that you know your old factoring stuff from back in the day, like difference of squares, difference in sum of cubes, how to factor a trinomial, however it is that you do that. And there's really not that many steps. We're just going to factor. That's like the main important thing. Try to factor the numerator, denominator, factor as much as you can. Simplify, cross stuff out, and then we're done. So here I have an example. We're going to start with multiplication first. Here is two rational expressions being multiplied to each other. So I'm just going to factor and just factor some more. So we could pull a GCF out of this, which is a 5. So we get 5x plus 1. Can't factor the bottom. Got a trinomial on top. Two numbers that multiply to give you 4 and add to give you -4, and this is the difference of squares. So you get x plus 1 and x minus 1. And the best part about this is where you get to cancel stuff out. So these x minus 2's cancel, and the x plus 1's cancel. So our final answer is, you just get the 5 on top, and the x minus 2. And on the bottom, we just have x minus 1. So this would be the answer to our first example. Okay, so here's our second example, and I'm just focused on factoring. So this is a trinomial. What is that? Like 2 and 6. So we get this is the difference of squares, so it's x minus 4 and x plus 4. Factor out a GCF of 4. And then here, I think we already looked at this one. It's x minus 2 and x minus 2. So here comes the slashing. Let's see what you could slash off the x plus 4. And this x plus 4. You slash off the x minus 2 and the x minus 2. And it looks like that's it. So on top we get this 4 right here. And then the x minus 6. That's all we have on top. And then on the bottom we just have x minus 4. And x minus 2. And don't bother distributing this in. We like to keep things in factored form. Alrighty, so moving on to the third example. What stands out about this one is that the leading coefficient is not 1 when you're looking at the trinomial. So I'm going to go ahead and do the throwback method. I've done that in my old factoring videos, but you can go ahead and solve it however you like. So I'm just going to bring these 2 back first of all. Bring this 2 back, multiply it with the 7. Bring this 2 back and multiply it with the 3. That's why we call it the throwback method. We just throw it back. So we got x squared minus x. This becomes x squared plus 13x minus 14. This is going to give us x squared plus 5x minus 6. So I haven't really done anything yet, except with these 2 guys, because now the leading coefficient is 1, and I'm comfortable factoring those. So here we go, factoring this, we could factor x out, so we get x minus 1. Factoring here, we get x plus 14, x minus 1. Moving on. That looks like the 3 and the 2. Take care of that. Wait a minute. I didn't factor this correctly. Sorry about that. It just shows you that you really need a rusty, so everybody needs practice. So this looks like x plus 6, x minus 1 case, so that looks better. Here, we get x plus 3, x minus 1. So you want to really be careful, alright? Now, the thing with the throwback method is it's not a legal move, so you have to be careful. I have to account for multiplying the 2 on these 2 guys. So on these 2 guys, I have to account for that by dividing by the 2, only on the numbers. So don't forget that. That's like the biggest part about the throwback method. So you have to do that. And if they divide evenly, that's great. It's just going to give us a 7. If they don't, you just bring the 2 back. So the 2 is going to have to come back here and here. Here it's going to get simplified to 3, and here it's going to get simplified to 7. So let's see what we get now. We got x minus 1, x plus 3. Now if the 2 comes back, it'll be 2x minus 1. So since everything was being multiplied in the numerator, I just wrote it out like this. So we got on the denominator x plus 7. Bringing the 2 back. And x plus 3x minus 1. So let's see what cancels here. These 2x minus 1's cancel. The x plus 3's cancel. And the x minus 1's cancel. So there's going to be a lot of canceling, which is normal. So we just get an x on top. And on the bottom we get an x plus 7. So this is our final answer, but I want to point out a huge mistake that students make is they try to cancel out these x's here. So you can't do that because this is one whole thing and this is another whole thing. You want to treat it like that. If you were to cancel out the x's, you'd only be canceling off a part of it, and you can't do that. So just keep that in mind. Okay, so moving right along, we have some more examples. Again, this is the case where the leading coefficient is not 1, so you're going to have to do the throwback method. So I'm going to have to do that here. Multiply the 3 there, bring this 2 back, multiply it there. This guy is fine because the leading coefficient is 1. This guy I'm going to have to bring the 3 back and multiply it there. Okay, so let's see what we get now. We get x squared plus x minus 30 over x squared plus 3x minus 4. This guy's fine. Here we get x squared plus 7x minus 60. So did I do that right? Right. Okay, so now we just factor it like normal. So it's like a 6 and a 5. This looks like a 4 and a negative 1. This looks like a 3 and a 4. And this looks like a 12 and a 5. Alrighty. So again, with the throwback method, remember which ones you brought it back to, and you're going to have to divide by that number now. So on the top, I multiplied the 3, so I'm going to have to divide these guys by a 3. Here I brought the 2 back, so I'm going to have to divide these guys by a 2. Not the variables, just the numbers. This guy I brought the 3 back, so I have to divide it there. Okay, so just keep that in track. This will give us a 2. That'll have to come back. This will give us a 2. That'll come back. This will give us a 4. And that'll come back. So let's see what we get now. We get x plus 2. We get, bring in the 3 back, we get 3x minus 5. X plus 4, x minus 3. Just writing out everything in the numerator, it's better that way. On the bottom, we just get x plus 2. Bring in that 2 back, we get 2x minus 1. X plus 4. And bring in that 3 back. So here comes the greatest part of the day. These x plus 2's cancel. This 3x minus 5 cancels with this 3x minus 5. And that's about it. So we get x plus 4 and the x minus 3. That'll be all divided by, wait a minute, why didn't I cancel out this x plus 4? These x plus 4's also cancel out. So on the top we just get x minus 3, and on the bottom we just get 2x minus 1. So that'll be it. Just be careful, there's a lot of stuff going on. I'm prone to making a lot of mistakes myself, so with this section you gotta be really organized and